when you're factoring a trinomial, something that's got three parts to it, hence the prefix tri, we're basically playing a little game. As long as the coefficient of x squared is 1, here's the game that you're playing. You want to find two numbers that multiply to equal the c value, the last number in your expression, while at the same time those two numbers need to add up to the b value, the coefficient of x, the number in the middle. So that's sort of the game that we're playing. Two numbers that multiply to equal the number at the end, while at the same time add up to the middle. So it may not be the most exciting game to you, but think of it as a game. So let's go ahead and factor this trinomial. Notice my a value is 1. This method only works if the a value is 1. There's a different way to do it if your a value is not 1, which I'll show you in another video. And what I do, if the numbers don't just jump into your head, is I make a list of my multiples of that last value. So multiples of 18 include 2 and 9. It also includes 3 and 6. And then don't forget that 1 and 18 is also a combination that would work to equal 18. People sometimes forget about that combination. So that's the complete list of my factors of 18. And if you have a hard time finding those, then feel free to use a calculator to make your list of factors. Now I have to choose from those three options the only set that also add up to positive 11. So 1 and 18 don't add up to 11, 3 and 6 don't add up to 11, but 2 and 9 do. Now when you make your list, you're also, sometimes you'll need to manipulate the signs depending on if you need to multiply to a positive or negative number. So keep that in mind as you do these. You could have had -2 and -9, although that wouldn't work in this example. So knowing that 2 and 9 are my factors, my numbers, the way that this factors is we're going to have two sets of parentheses. The first spot will be x because, again, we're sort of reverse multiplying when we factor. That's all factoring in is. And if I were to remultiply this, I would have, at some point, I would end up multiplying x times x, which gives me x squared. Since 2 and 9 are my factors, put those in the last spots, and it doesn't matter what order they go in. If you flip the factors around, you could easily, or so just the same as written this answer as x plus 9 and x plus 2. If I wanted to check these, I could graph both parabolas. I could make them into y equals and graph my answer, graph the original, see if they're the same parabola. But that's how you factor a trinomial. So I've got a few down here that would probably be helpful for you to pause the video and try. Factoring is one of those really basic algebra skills that you need to just practice and get good at. So if you want to pause the video and try those, go ahead and do that. Otherwise, I'll just go through and explain if you want to check your work, or if you're just watching for the fun of it or just to learn, then go ahead and keep watching. So let's factor these trinomials. So again, I want to note that my a value is 1. If the a value is not 1, this method won't work. So the bottom row, we'll have to take a look at another way to do those. So I want to find two numbers that multiply to 2 and at the same time add up to positive 3. So make your list of factors. I think that list helps, especially as the numbers get more difficult to work with. So the multiples of 2, there's only one option. 1 and 2 are my only options. Good thing that 1 and 2 add up to 3, otherwise this wouldn't factor, which sometimes happens. Not everything can be factored. So 1 and 2 are the numbers I need. I need them both to be positive. So this would factor into x plus 1 and x plus 2, and again, the order does not matter. If I wanted to check this, I could graph it, or I could use the box method to multiply this and see that I end up back where I started. Next up, I have a 1 in front again, so I want to list my factors of positive 10. That's 2 and 5, but don't forget 1 and 10 are also factors that would multiply to equal 10. So I have two options this time. I need the one option that adds up to 7, so that's 5 and 2, which means this factors into x plus 2 and x plus 5. Okay. For the bottom row, I've already kind of pointed out, we don't have a 1 in front this time. So using that method I just showed you will not work. Do not try to find two numbers that multiply to 28 and add up to 18. You probably won't be able to find any, and even if you do, they're not going to be the numbers we need. Instead, we need to get a 1 in front. And so what I'm going to look for first, always, no matter what kind of factoring I'm doing, I'm going to be looking for a greatest common factor first. Those top examples didn't have one, so I didn't bother to check, but I probably should have. Always check for a greatest common factor. So in this case, I can see that all terms are divisible by a 2. So what I'm going to do is divide out a 2 or factor out a 2, and remember in parentheses we'll put our leftovers. So once I've divided by 2, I get x squared plus 9x and then plus 14. And now what I'll do is I'll go one step further, and now I can factor this trinomial in the parentheses because now I do have a 1 in front. So let's use the same thing we talked about up above. We need two numbers that multiply to 14 and add up to positive 9. So my options are either 1 and 14 or 2 and 7. Those are the factors of 14. 2 and 7 is going to be the set that we need that adds up to 9. So the parentheses will factor one more time, into x plus 2 and x plus 7. If you do that as your answer, though, you're wrong. There's one little bit you forgot about. Don't forget to bring that greatest common factor down as part of your answer. So there's going to be my factored expression. And again, I could check that with graphing or check that with multiplying. Okay, and last up, once again, we have to get rid of that 3 in front. So the good news is we do have a greatest common factor, and that is a 3. And as we discussed in our greatest common factor video, anytime that first term is negative, you want to make sure you pull out a negative number with it. So negative 3x squared divided by negative 3 gets you an x squared, or a 1x squared, which means I could factor this problem one more time, as long as it will factor. 18x divided by negative 3 is negative 6x. Don't forget to change the signs like we did, because we divided by a negative. And last up, I've got plus 8. So I now have a 1 in front. I can now factor using the trinomial trick I showed you at the beginning of this video. So two numbers that multiply to 8 and add up to, look at this, now we have to add up to something negative. So actually think about these problems before you just sort of jump right into them. I need two numbers that multiply to equal something positive and add up to something negative. So what that's telling me is I must have both negative signs. Two negative numbers will be positive, and two negative numbers would be positive if I multiplied them. Two negative numbers would add up to something negative. So sort of play that game too as you're going through these. Make sure you're thinking them through. So to multiply to get 8, I've got 1 and 8, and I've got 2 and 4 as options. But as we just said, my signs for both of those have to be negative. It's the only way to get a positive number when I multiply and a negative when I add. So this must be my option, which means I can factor this to x minus 2 and x minus 4. And again, I could have switched the order if I wanted to. Don't forget, though, that's not the answer. I need that negative 3 greatest common factor as well. So there's my completely factored answer.